Kimberto presents, as part of a project for Sonoma State Geology Department, Garnet Hill in Ely, Nevada, and a visit to the Great Basin National Park in White Pine County, Nevada. We leave the Delta, Utah area and drive west on Highway 50 in Utah towards Nevada. From Delta, Utah to Ely, Nevada is about 172 miles, or a little less than a 3-hour drive. The Great Basin National Park is a little more than halfway to Ely from Delta, Utah. The very desolate Highway 50 between Delta and Ely is touted as America's loneliest road. This is a topographic representation of the Highway 50 area in eastern Nevada. The basin and range with its alternating mountain ranges and valleys is very apparent here. Highway 50 winds its way through the valleys towards breaks or low spots in the mountains where road construction has less obstacles. Notice in the upper left-hand corner the huge open pit copper mine. We spent several hours here at the Great Basin National Park on our way to Ely from Delta, Utah. There really is a lot to see at this remote park, and it would be worthwhile to spend a couple of days here. Here is the Wheeler Peak overview looking towards the 13,000-foot Wheeler Peak. There's actually a small glacier at the base of this peak and a grove of bristlecone pines. At one point, the documented longest living tree in the world was located here. It was known as the Prometheus tree and was 5,000 years old. The Lehman Caves in the Great Basin National Park extend about a quarter of a mile into the limestone and marble and are located at the base of the Snake Range. You must plan ahead and make reservations to go on a guided tour of the caves. The tours take either 60 or 90 minutes depending on which ones are available. The drive from the Great Basin National Park to Ely, Nevada, where Garnet Hill is located, takes about an hour. While in Ely, you might consider taking a ride on a century-old steam train at the Nevada Northern Railway. They have day and night trips available, and they also have, believe it or not, a geology train, where a local geologist explains the local geology and local mining during the ride. Planning ahead is a must if you want to take the geology train. Garnets are a group of neosilicate minerals. I will discuss garnet chemistry and silicate minerals a little more in a moment. Different garnets have similar properties and crystal forms, but may have differing chemical compositions. There are 6 main species in the garnet groups. Garnets are commonly found in metamorphic rocks, but some, like the garnets here at Garnet Hill, are igneous in origin. Here's a chart of the garnet species. Looking to the left is the general formula for garnets, A3, B2, and then SiO4, which is a silicate group. If the A is fixed and it's always calcium, indicated by Ca pointing towards the bottom of the chart, and the B is then substituted, you get the bottom 3 groups of garnet depending on what's substituted for B. You get grossular garnet, uvarovite, and andradite garnets. However, if the B is fixed and it's always aluminum, indicated by Al, you can see pointing towards the top of the chart, and then the A is substituted, depending on the substitution for A, you get almandine garnet, which are the garnets that are found here at Garnet Hill, Nevada, pyrope, and spessartine garnets. As we saw from the previous chart, Garnet Hill garnets are almandine garnets, which are iron aluminum garnets. These garnets grew in cooling rhyolitic lava. If you saw my Topaz Mountain video, this is a similar process to how those topaz crystals were formed. We know these garnets form in a high temperature, low pressure environment because they're associated with tridymite, which is a high temperature polymorph of quartz. I know that's a lot of words, but all a polymorph is something that has the same chemical composition but occurs in different crystal structures. Garnets are silicates. Let's review what silicates are. Well, most minerals in Earth's crust are silicates. The silicate tetrahedron, as shown here on the right, is the basic structure for silicates, and is formed with one silicon atom surrounded by 4 oxygen atoms. The different groups of silicates have different bonding arrangements of this silicon-oxygen tetrahedron. There are 7 groups of silicates classified by structure. Here are the 7 silicate groups classified by structure, and by the way, the oxygens in the silicate tetrahedron are shared. Garnets are neosilicates, see in the upper left-hand corner there, where no oxygens are shared, as is topaz, which we've already encountered on this trip. There are mineral examples for each silicate group listed. The samples indicated in red are minerals we will encounter on this trip. From downtown Ely, Nevada, you drive west on Highway 50 for about 4.5 miles. There you'll see a BLM sign. You take a right, headed towards Garnet Hill. After about 3 miles on a dirt road, you'll see a parking area. You can get out there and go hunting. We've arrived at Garnet Hill, Nevada. Most of the area near the road is very well picked over in terms of surface collecting. We did do some digging and found a few small garnets. However, if you hope to find some nice examples of garnets in matrix, which is the way I like minerals, you're going to have to do some more serious digging with picks and pry bars. Here's a very nice example of garnet in quartz or maybe tridymite from Garnet Hill, Nevada. This is not mine. If you recall the large open pit copper mine on an earlier topographic map, this is the view of that mine from Garnet Hill. We are leaving Ely, Nevada and driving south for about 150 miles on Highway 6 and then on Highway 318 to the Alamo, Nevada area, where we will visit some sites with geologic evidence of the late Devonian Alamo impact event. Later, we will drive on the extraterrestrial highway, Highway 375, past Area 51, and head towards the Lunar Crater Volcanic Field. See you there. Thanks again for watching Garnet Hill in Ely, Nevada. Please, if you enjoyed this video, check out our other videos.